Welcome. Let's begin. Let's begin with this seminar. This seminar about Open BIM, about workflows for structural fabrication. My name is Afonso Solac. I am civil engineer and I work as marketing director here at Cype. I'll be here today with you talking a little bit about these aspects, these topics. Okay, a very interesting topic, something that is very popular in our seminars during the past months. We have been talking a lot about steel design, steel detailing, structural fabrication. And in this section, I've prepared here a little presentation to share with you some options that we have to apply the Open BIM technology to boost the industrialization of the AEC sector, in this case, proposing some workflows for structural fabrication. Okay, so this seminar, it's part of a cycle of seminars we have been transmitting in our LinkedIn, in our YouTube channel, also using the GoToWebinar platform, this series of seminars. So if you want to see the other seminars that were transmitted before, you can check it in our website, looking for the video gallery where you can find these recordings. Okay. If you have any doubt, any comment, please feel free to leave your comments in the sessions that we have in all the platforms, in the chats, in the comments area, and we will be trying to answer these comments during the presentation. Okay, so let's begin. I'll divide the presentation in two main parts. In this situation, I've prepared a theoretical part using a PowerPoint presentation to show the main workflows that we have. Probably that's going to be more than a half of the presentation, but I swear that I will try to do something very visual without too much text to be interesting. And then in the second part, we will see a little example opening some softwares and showing how this theoretic part will be applied in a in an example. Okay, so let's begin. The idea of today is just present a little bit our company. If it's your first time here in our seminars, we are Cype. Cype it's a Spanish company that develops softwares for architects, civil engineers, structural engineers, electrical engineers, mechanical engineers. So we have softwares for all the disciplines relates to the design of a building. Then we'll see a little overview about the Cype's ecosystem, just to introduce a little bit how our software works, and then jump for an example related to steel structure and see this case of manufacturing of these structures. And in the end, as I said before, we will see an example about this theoretic part, showing a little workflow using Cype 3D, Cype Connect, and Turbine Steel that are three of our main tools for steel projects that are available in our portfolio nowadays. Okay, so let's start. Our company, very fast. Probably most of you already know our company, but if you don't, this is Cype. Our company was founded in 1983, so we have 40 years of more than 40 years of experience developing softwares to the AEC sector. Nowadays, our team it's around 200 professionals working in the software development. So we have software developers, civil engineers, structural engineers, electrical engineers developing these softwares, and then our other teams like the marketing department, the sales department, the technical department that can help you if you have any doubt using our software. You can contact our technical department and the other professionals working at Cype. Our portfolio nowadays have around 150 different tools. Most of them are open BIM tools that are, it means that they import or export IFC files or other formats in that are standard files. And the software is sold using a network of more than 30 distributors around the globe. Okay. As I said before, we started in 1983, and after a lot of expansions, new solutions, a lot of innovation, our main goal nowadays is try to contribute to the digital transformation of our sector, digitalizing the AEC sector. It's not an easy task, but we are trying to help with our solutions, our software. We are trying to help in this digitalization. Okay, so yeah, that's a little bit of about our history. Talking a little bit about our software, in this case, some overall aspects. We are not entering actually in the steel fabrication yet, but just to introduce how our ecosystem work, let's talk about the main four categories that we use to classify our software. So we have softwares for architecture, for structures, installation, so mechanical, electrical, and plumbing installations, and also for project management. Of course, today we will be focusing in the structures, so the red part, the red category of our portfolio. But you see, if you look in our website, in our catalog, in our and also in other videos that are available in our channels, that we have softwares for all the areas from A to Z to develop a project of a building. Okay. Talking a little bit more about Cype's ecosystem, and now entering in one of the main aspects of this webinar, let's try to understand what is the Open BIM concept. Okay, so Open BIM, there is a famous acronym that is BIM, but now we are adding this little word open before this acronym. What is this difference? So when we talk about Open BIM, we are talking about a system or a process or a workflow where the information can be sent from one software, from one application to a second application using a standard format. It means there is a type of files using very simple words, okay, that can be used as the exchange file, or that can be used to exchange information from one software to another. There are different standards that can be used for this purpose, but the most common format used for it is called IFC. Okay, so there are different software developers like us that import or export IFC files. And if yes, a software imports or export IFC files, we can get the file from one software and then use the information from this file in this second software. Okay, it opens a lot of possibilities because then you can use, for example, different softwares from different softwares developers in a same workflow. And we will be seeing during this presentation that are some of the workflows that I will propose to you. We will also combine softwares that are not necessarily developed by Cype in a same workflow if you already work with these other softwares. Okay, usually to create this interaction between softwares, we usually create what we call a federated model. It means we'll create a project that will be generated step by step, adding layers of information. Usually these layers of information, they are different files, different IFCs. So I can have in a same project an IFC with the architectural model, in a second moment the structural model, then the plumbing installation, then the HVAC installation, and step by step, I will add these layers of information, created a model that is federated. Okay, to do it, we must have a place, a folder somewhere, a space to save, to locate this information, to allocate this information, allocate these IFC files. And usually these folders, they are available in the cloud. They are cloud-based servers where we can then send these IFCs to this space. And if we need to work in a team, for example, we can then share this space with other people. And then this process will be not just a collaboration using two different softwares, but could be also between two different um, um, agents in the project, two different professionals, for example. In our situation, Cype have one space like this. It's called BIMserver.center. And if you are working with our software, all the softwares that we have, they are connected to this platform, and it's part of the project. You don't have to pay to use it. It's part of the features that we include in our softwares. So BIMserver.center is our common data environment. Okay, if you are already working in BIM or even in Open BIM, you probably already heard about this acronym, the CDE. Okay, so it's the place where all the models, all the IFCs will be saved and our federated model will be created. Okay, we'll see some examples in a while. To illustrate a little bit this situation, just showing here the CDE, the BIMserver.center platform in the center, all the different disciplines that are necessary to create a project, they will be connected uh, using this BIMserver.center or this common data environment. Okay. Just to show an example, this is not yet a steel structure, but just to show how this model, this federated model can be created using our system. Let me show this simple building, this simple house that I've been developing before. Let's imagine that in a first step, I have a model, could be an IFC, for example, with the topography, the geometry of the terrain, where we construct our building. Okay, there are different softwares in the market that can be used for this purpose to develop the topography or the terrain models. In our situation, we have an Open BIM tool called Open BIM Site that have this icon here that can be used for that purpose. I've used this little software to create a little model here. But let's imagine that in a second step, I use this system to design, for example, the structure of the project using, in this case, Cype. That is another software that is available in our portfolio, in this case for the design of reinforced concrete structure. So here in my federated models, now I have two layers. One layer is the terrain, the second one is the structural model, different softwares that were integrated because we have these IFCs or this standard and also our common data environment. And this process could actually we could increase the number of layers of information. For example, another layer of information could be the plumbing installations. A third software, in this case, Cype Plumbing, was used to the design of these plumbing installations. Then we could increase, for example, with the electrical installations, in this case, another AFC, another software, in this case called Cyplec, or for example, then the HVAC, the air conditioning installations, CPHVAC. And of course, we could finish that, for example, adding more and more layers of information until we finish the project. In this case, I finished the project using Cype architecture. That is this software that we have here for the design of architectural models. Could be any other software that exports AFC, ArchiCAD, Revit, any other software that is a BIM software. Of course, that's the process of developing the project is not necessary. The process that I've showed to you here, actually, this little simulation that we saw, it's more the order that will be constructed, the building will be constructed, but just to illustrate how this federated model can be created in different layers using different softwares, I think it's a good example. Okay, just showing some deliverables. It means some results that we can obtain when we create this federated model. One of them, it's for sure, it's the model. The model itself, it's with a lot of information. It's a huge database with geometry and then a lot of information that is introduced in all the parts of the model. Remembering the BIM model is not just geometry, it's actually information, building information modeling. So we are modeling the information of the building. Okay, so the geometry, it's one of the informations that are available in this huge database that is the BIM model. Okay, uh, from these softwares that are BIM softwares, the different softwares that we have in our portfolio, it's not necessary for the structure analysis, could be thermal analysis, energy efficiency, design of installations, telecommunication systems. We will also have a lot of results that are based on, that are actually reports, the reports of the loads, the thermal loads of the building, the reports of the strength of the Wi-Fi network, then reports with the codes used to the design of the connections of a steel structure. There are a lot of type of reports that can be then extracted from these BIM models after some analysis, some design, after we use the softwares for their own purposes. Okay, just to illustrating this little slide here, these reports here at Cype, they are very clear. They have a nice format. You can personalize these reports, changing some aspects of the report, some graphical aspects, and then of course you can export it for different formats. For example, if you want to then open it on Microsoft Word and edit something, delete something, add something, the system is very flexible. Another type of results that of course are necessary when we create a project and you can extract from a BIM model, it's the drawings. For example, here I have just some examples of drawings of plumbing installations, some connections that were designed using one of the softwares that we will show to you here during the presentation. Or for example, here some details of a system for ventilation systems, or even here for air conditioning. There are different ways to create these drawings, different styles, not necessary in color, could be in black and white, vectorized or not. There are different ways to create these systems. In some cases, we will have automatic generation of these drawings. In some situations, we will be a little bit more flexible, and we could personalize a little bit more these these details. But the main aspect that I would like to share to you with this slide is there are a lot of ways and different situations where we can extract drawings from the models that were created, models that in most of the cases were analyzed uh, before. Okay. And for example, another situation that I think it's very interesting is that if we have this model, we will have a lot of quantities that are available in this database that is our model. And then it's going to be very easy to have a view of quantities to estimate the cost of the building with this model. So we have here solutions in our portfolio that are specific to the generation of the view of quantities of the project, uh, reading these IFCs that are available in our folder in the BIMserver.center platform, in this federated model. Reading these IFCs, we can then connect the quantities from this model with a cost database, okay, and then have the cost of the building, have the view of quantities, okay. So this is one of the uses that we can have, or we have for the model that we are creating. Why I'm showing all these details, why I'm showing all these processes that are not actually still design, because now we'll jump to a second situation, our next topic that is going to be focused on still design, but that the philosophy or the concept behind it, it's exactly the same. We'll be using different tools, and we'll be using the IFCs to send information from one software to another, creating this federated model. And although I showed to you just the structural design and then the preparation of it to the manufacturing of the structure, you can imagine that the federated model uh, could be a little bit bigger with more layers of information, because we could integrate, for example, the steel structure with the architectural model, with the plumbing design, or any other discipline that is not the steel structure design itself. Okay, so let's jump to it. So let's talk about softwares for steel structure, or steel or structural design, in this case focusing on steel structures. Okay, here at Cype we have actually three main softwares in for this area. Okay, the most famous one, and the first one that we've created some years ago, it's called Cype 3D. Okay, Cype 3D, it's the software where we will model our structure, and it's the software where we analyze the structure. So here we will select a code, for example, the Euro code, the British code, the American code, or there is a huge list of different countries available in the software. Here we also select the codes that we will use to the wind loads, or actually here we use the seismic analysis, the wind loads. Actually, we introduce these loads using the tools that are available. Here we can select the types of materials that will be used with all the mechanical properties of these materials. Here we'll actually develop the structure itself and then create an analytical model of this structure, apply some loads, and then design the structure. This is the main purpose of Cype 3D, structure analysis. You see in a while when we start talking about the workflows that in some workflows actually we will not use Cype 3D because possibly I already have this phase developed in another software or even using any other method that is not actually a software. So if I need to calculate to analyze the structure in some workflows that we'll see, Cype 3D could be the best tool. Okay, and if you already have the structure analysis phase finished in your process, no problem because there are also some workflows available for it. A second software that we will be talking today is called Cype Connect. Cype Connect is one of the brothers of Cype 3D. Actually, it's the name help us to understand what it's the main purpose of the software. It's for the design of connections. Design of connections between elements that could be two steel elements, two or more steel elements, but also timber elements or even the connection of these elements with concrete elements. For example, the anchor plates of a foundation. We can connect a steel column with a concrete element, and we can design these elements. This software, actually, the idea here is to develop the model of the connection and analyze this model using the finite element method, uh, then getting these results from the finite element method and comparing these results with the limits that are available in different codes that can also be selected in the software, and then check if it's these connections they are safe or not. Okay, and there's a third software that is called Strubing Steel. That the main purpose of this guy here is steel detailing. Actually, if we get the information from this guy, start developing the design of the connections with this one, then we can finish and have a detailed model here at Strubing Steel. And this is the actually the software that will be used then to generate the models for fabrication, for manufacturing. Okay, and remembering establishing a analogy with the little model that we saw of the building some minutes before, these are different layers of information. So here I can have one AFC, here I can have another AFC, and here I can have another AFC. And of course, we'll send the information to one software to another because they are all connected using that folder that I've been talking before that is in the cloud using the BIMserver.center platform. Just a little detail, these softwares actually, we are talking about Cype 3D and Cype Connect, they are powered by the OpenSys. OpenSys, it's a calculation engine developed by the University of Berkeley in California. And when we are talking about non-linear analysis that sometimes are necessary for the design of structures, we use the OpenSys system, and it's integrated at Cype 3D and also at Cype Connect. Okay. So let's start talking a little bit about the workflows. We will divide these workflows actually in four main parts. The first part that we'll see it's the introduction of data, the data input. The second part it's going to be the structure analysis. Okay. The third part is going to be the design of connections, and the fourth part is going to be the generation of a model for manufacturing or the steel detailing. Okay. Let's open this part and let's start seeing what we have here. Okay, when we talk about the first part, the data input or the introduction of information, we have actually four main ways to introduce information in the system. Okay, the first way I've actually simplified it a lot. I called modeling the structure manually. What it means? If you don't have the structure, if you don't have anything, and you want to start from scratch using Cype, you have tools to do it. Okay, so you can just open the software. You see it's going to be the software that's going to be available here, and you can start modeling because the software itself have options to introduce the structure. There are different ways. You can add it using the same tools that we will have in a CAD software, but you can also introduce the nodes using, for example, a TXT or a CSV file, introducing these nodes automatically from TXT file, or you can use references like PDFs or even JPG files to then design the structure using this reference. I've simplified here uh, 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 telling or using the word manually with the idea that is you don't have the geometry of the structure. Okay, you want to introduce this geometry using Cype. So this is the first option that we have. The second option is if you already have the structure of the geometry of the structure in a CAD format in DWG or DXF, you can get these lines from the CAD format and transform it into structural elements in bars, for example, or if you have surfaces in your CAD file, you can transform it in shells. And then with this information, you apply loads and run an analysis. Okay, so the second option that you have here is uh, getting information of the geometry of the structure from CAD formats. Okay, there's a third way, that is if you already have a model, if you already have an AEC, if you already have a BIM model, for example, let's imagine you already developed your model, you already analyzed the structure, and you have the structural model developed with Autodesk Revit or with Tekla or with ArchiCAD or any other software that exports AFC. So this could also be information that can be used as data or data input. Okay. And there is a fourth situation, that is if you already developed your analysis or your structure is already analyzed with Cype 2000 or ETABS, you can export XML files from these softwares, and then this information can be introduced in the system for different purposes that we'll see in the next steps. Okay, so if we uh, keep going, just to show you here a little bit example, if you have, for example, a geometry like this in DWG and DXF, you can send this information to Cype 3D, and at Cype 3D we will transform these lines and surfaces in an analytical model that can be then analyzed. Okay, if you already have a model, I'm sorry, here it's a timber structure. The idea is the same, because actually Cype 3D and Cype Connect, they also can be used for timber projects, not steel projects. If you already have this model, it means that you don't have to design the structure itself. You don't have to analyze it, because if you already have a model, you probably already analyzed it before, and you can send this information to Cype Connect to then design the connections. Okay, and of course, I'm sorry, if you use this guy to then generate a structural model, you analyze the structural model in Cype 3D, you can then get the information from Cype 3D and send it to Cype Connect. It means that it's missing a little arrow here connecting these softwares. Okay, actually, when we start with an IFC from that is not developed with Cype 3D, it means that we jump one step, because this step was already done before using another tool. Okay, this is just a little example. If we work with ETABS or SAP 2000, the situation is going to be very similar to this one, although the format is not going to be an IFC, it's going to be a XML file. Structure analysis. Structure analysis is the second step, so it applies just to the first two situations of data input. It means I will create the structure using Cype 3D and then analyze the structure, or I will import the geometry of the structure from AutoCAD or any other CAD software, and then design the structure at Cype 3D. In these situations, we don't need the structure analysis, because actually, if you already have the model in a level of development like the level of a BIM model, you probably analyze it before using another tool. So the structure analysis, it's Cype 3D. Cype 3D, as I said before, it's a software for this purpose to introduce the geometry of the structure, generation of the analytical model, creation of the load cases, and then applying these loads in the structure, and the software will design the sections, or will select the best section for each one of the elements of the structure according to the criteria of a code standard that was selected in the beginning of the project. As I said before, it's powered by the Open system. Okay, just showing here some little examples, some pictures about the software. In a while, we also open the software to see a little bit more about it. Okay, so here just showing a node where we can see the moments, and also, yeah, just the moments here in different axes. Okay. Design of connections. Design of connections is actually here where everything is gonna be connected, where the workflows, they will be transformed from 4 different situations to same situation. Okay, design of connections at Cype Connect. It means if I started modeling the structure with Cype 3D, or importing the CAD formats at Cype 3D, if I already analyzed this structure here, I can now send this information from this part of the project to this part of the project, where I can now design the connections. It means that all the loads that were introduced here, all the load cases, the geometry of the nodes of this structure, that they can be sent from here to here, and then here I can design the connections. And the situation here, it's gonna be similar. If I already have this structure, I can import these files here, design the connection here, or if I'm using these guys here, SAP 2000 and RE using these XML files, there is a little tool available at Cype Connect that can be used to import these XML files. Something very interesting here is that it's an XML file here. If you have some load cases and some loads in these softwares, because they are softwares for structure analysis. And these load cases and these loads, they can also be exported from SAP and ETABS in this file and imported here at Cype Connect. So it's going to be something similar that works when that we have here at Cype 3D. Okay, so you don't have to introduce all the loads in each one of the connections of the project again, because this information, it's already mm, calculated by the software in a previous version. Okay, so talking a little bit about Cype Connect, here I have the arrow that was missing, so I can send this information, that is the analytical model of the structure, to Cype Connect, where I will design each one of the connections. Okay, just showing a little bit the interface of Cype Connect. Cype Connect also use OpenSys for the analysis. So Cype Connect actually have a main toolbar where we will have different operations. So it's using the buttons of these toolbars that will create end plates, string the different plates that we have, move elements, add bolts, add welds, add openings, add anchors, stiffeners, adjust bars. So it's combining these operations that will model the connection itself. Okay, for each one of these operations, we'll add an element in this list that you see here in this section that is highlighted, and each one of these operations will then have different parameters. For example, here I have an operation that is to introduce a weld, and I can see the elements that will be welded, the type of weld, the position, the size, the material, everything related to the operation weld that was available here. And when I click it, I introduce it here in this area. Okay, for each one of the operations that we add here, we'll have we'll see the changes here in the 3D model. And then in the end, if we have any clash or any element that is not compatible with another element, we will have here some warning messages telling us that something is not okay, that must be checked before we analyze the connection itself. There are different types of connection, as I said before, for example, between steel elements, between wooden elements, between in a mixed situation like this, or even the connection of these elements to concrete elements. Okay, As I said before, the introduction of loads and load cases in these nodes to then design the connections could be manually. It means if I don't have this information because my IFC model don't have this information, there is no problem. You can introduce this information in each node and then analyze the structure. There are some options that you can paste from Microsoft Excel tables. For example, you can have a CSV with all these moments, shears, normal forces, and you can paste it in the software, or you can import automatically these loads and load cases from a BIM model if you are using Cype 3D, or from the XML file if you are using SAP 2000 or ETABS. Okay. Some results related to connections. Okay, for example, the first or the main purpose of these connections is the code checking. So once you selected one software, one standard, one code, then you have a analysis option where you have results that will get the different results from the analysis and compare with the limits of the code. And then you have situations like this. For example, here I think I selected the Filipino code, and according to the Filipino code, this topic here, there was a limit of 40 kilonewtons and I have just 5. So for this topic it's okay, and the software will tell to us if it's something it's not okay, and will point the topic from the code that is not okay with the results, with all the details, with the formulas, and then we can decide what change we will do in our model to then try to have a safe condition, okay, a safer condition. Another results that we can have here that can help us decide how we'll model the structure is the maximum demand capacity ratio. It means in a scale from 0 to 100, we'll see how much of the resistance of each element we are using. In this case, for example, the red elements, they represent situations that are not safe. And for example, this bolt that you can see here, it's probably not safe. Okay, the green elements, they are actually, we can see in this picture, it's going to be easier. It's from a 0 to 100%. So according to this scale, we can see where are the critical elements. We also can have here the results from the von Mises stress to then try to find parts with excess of tensions, or even the equivalent von Mises deformation, and also the displacements of the elements in this node, in this connection. Okay. We can also run here a linear buckling analysis. So we are talking about local buckling analysis. We have here the different modes that we can have. In this little example, I have 3 modes, okay, and according to the different combinations of load cases that we have in the project. So we can run this type of analysis too. And we can also calculate the rotational stiffness of the elements, where we'll classify them this this uh, this connection as rigid or semi-rigid. So in this situation here, for example, we see an example of uh, a semi-rigid connection. Okay. Models for manufacturing. So let's go to the last part, okay? This part here, Strubing steel, okay? If you already have the structure coming from here or coming from here, you already have some connections that are designed. So you can now go to Strubing steel and finish and have a steel, have a detailed model of your steel structure that can be sent then to manufacture. Okay, so in Strubing steel, actually here the idea is classify elements, numbering the different elements. Here we can create parts, we can create assemblies, we can generate tags to then activate and deactivate the elements, and then use this information to generate sheets, for example, specific sheets for parts, for assemblies, for joints, for the model, the complete model. And then that's the software that we use for this purpose. Okay, these are some examples of models that were detailed using Strubing steel, actually models that were designed with Cype 3D, that the connections were analyzed with Cype Connect, and then the were finished, or the steel detail was finished here at Strubing Steel. One of the main purposes of the software is to generate not just the sheets, not just the different results that we can get from the software, but generate the DSTV and the step files. These files, they are very popular in the industry of manufacturing of structures, especially for steel structures, because this file can be used then, could be sent then in the CNC machines. Okay, so you can just get your model, export it to DSTV and step, send for your manufacturer, and these files that could be then used in these machines for CNC. Okay, it's where we connect the BIM world with the manufacturing world. So here we jump from the project phase to the execution phase, or to the manufacturing phase, or to the fabrication phase. Okay, this is just a little detail, but it's very, very important in these workflows that we are presenting to you today. Okay, so you can come from different softwares, even from different softwares manufacturer, and in the end of the process, you can export this DSTV or step files. Okay, and there is also another option that is called IFC EM11. That is one specific type of IFC that can be also exported, and in some situations that can be used, because in this specification of the IFC format, you can also add all the information related to the manufacturing of steel structures. Okay. Other results, of course, here we can have the sheets in DWG, DXF, PDF. I'm just showing here some examples of different connections and elements. Okay, of course, we can extract it from Strubing Steel, or even also from Cype Connect. Okay, if you are not working in a process that is very automatic, as I said before, using the STV or step files, you can of course have your drawings from the model. Here, just showing that we can get the native file from this Strubing Steel and transform in an IFC without losing information. Okay, we can have different types of reports that we can get from Strubing Steel. For example, this is a report with the codes that were used to the analysis of the connections. Here we have different topics related to the checks that were made in the different plates of a connection, some aleatory reports that I've just selected to show to you some examples. Or for example, here the quantities of type of sections with the length, the area, the weight, or the quantities of plates that we have in the project. We can also export these files to the BIMserver.center platform and open it using the app that we have, that is also for free, and represent it in augmented reality. If you have a device like a goggle like this, you can also see these models in virtual reality, even in the real scale. So that could be very nice to check the structure before you construct it. Okay. So yes, these possibilities are available in these workflows too. Softwares for reinforced concrete structures. This situation that is using the BIM model and then using this model to fabrication can also be similar. We also have this a similar situation for concrete structures. Yes, we have. This is not the purpose of this presentation, but I just want to leave the message that for the reinforced concrete structures, we have a very similar process where you can start with a BIM model of an architectural model, for example, transform it in a model, in a structural model. The, then you have an analytical model, and this analytical model can be used to generate a very detailed rebar model. And this rebar model can also be exported to different formats, and some of them, like the BVBS, are formats that can be used to have a more automation in the fabrication process of these rebars. So usually the cutting and bend machines that are used for the production of rebars in a more automatic way, they import the BVBS file that can be generated from our system. Okay, I will not enter in more details about it, but just the message is something similar that we saw in the steel situation can be also applied for the reinforced concrete situation. There are other softwares, but the concept is the same. Okay, we are almost finishing our presentation. and we have here just like 10 minutes. So let me open here one example to show to you. Of course, it's an example that is already analyzed, already detailed, but just to show to you how these concepts that we saw in the theory, they are applied in the in the in the in the softwares. Okay, remembering that when we install the softwares for Cype here in the structures, we install this menu with a lot of tools. The structures category, we have Cype 3D, Cype Connect, and Strubing Steel, so you can install them. I have here in my screen now a model that is developed here at Cype 3D. This is the analytical model of our structure. We have here some tools to, for example, see the structure with a little bit more details. Here we can see the geometry of the sections that were selected, and we can also, for example, represent the color of the tags or the 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 layers that we've created here. Okay, so it's a very small model, but this is a model that could be imported from for example, just imported from a DXF or a DWG file, as we saw before, that could be introduced here using the different tools that we have to model the structure itself. Okay, um, and the analytical model was generated. Okay, just to show to you here that this is actually an analytical model, let me come back to the initial situation here. Here, for example, you have the external conditions that were selected. If I describe a bar or I edit a bar here, I can see that these bars have mechanical properties. Okay, so a section was selected with a series of sections here. Uh, we can have here define the behavior of the element, if it's linear or only tension, whatever. Here we have information that is mechanical information of the elements, and these different bars were grouped. We have here different sizes, or okay, and then of course some loads were applied. For example, here loads that are associated to different load cases, so the self weight, the wind in different directions. Okay, for example, if I get one of the winds, or even check this option to view all the load cases, I will see the different loads applied in the structure. Okay, here in different colors, some are uh, in pink, some in yellow. Okay, actually we can also change the background of the software and put it on gray or black, and then we can see a little bit better these loads if we want. Okay, and if we have the geometry, we have the mechanical properties of the structural elements, then we can analyze the structure. Okay, in this case I already analyzed it, but okay, let's analyze again. So here I can analyze the structure and see if the geometry that I've introduced to these loads, if it's correct or not, or even ask to the software decide for me which is the best section for each one of these elements. And for example, here in the results, I can see which one of the elements are checked or not. Okay, in my results, for example, the green ones are okay, but the red ones, they mean that the section that I've selected, it's not enough. So if I click here, I've selected the IP80, and of course this is too small, and the minimum section necessary to this part of the structure would be the IP 220. Okay, and here we can see how much of the resistance or the deflection of each one of the sections was used, and then if it's safe or not. Okay, so the software is very intuitive, and as I said before, it's a software for analysis. Okay, in this case here in the project, in the general data, I've selected before one code. In this case, I'm using the ACI 318, okay, from USA, but we have a huge list of codes from different countries here, and the results, they will be checked according to the criteria available in these codes. Okay. As I said before, this model developed here at Cype 3D, I can connect. Okay, here I can log in in the BIMserver.center platform. In this case, I'll just connect it with my profile. If I come back here, I will be connected. Now you see here my name. Here I can now connect this software to a project. Okay, I'll link this software with a project. And when I link with a project, I can then share the information from this software to the BIMserver.center platform. It means to that folder that we've been talking before, that where our federated model will be saved. Here in this moment, the software will generate for us an IFC. This IFC will be then available in the folder, because then I can jump to a second software. In this case, I have jumped to the Strubing Steel software. And here in the Strubing software, or any other software developed by Cype, we can then connect to the same folder and download this IFC, import this IFC to the software, and then keep working in a second phase of the project. Okay, in my situation here, you see that the same model that we've been talking before, it's already detailed here. So you can see that the connections are very detailed here. There are different connections. Actually, there are some connections that I still have to detail. It's not 100% finished here, but there is a lot of them that are detailed. Okay, and here actually inside of Strubing Steel, we have Cype Connect embedded. Let's say that we can run Cype Connect using the Strubing Steel interface. Okay, so actually when I edit one of these connections, okay, for example, get this one, we will run Cype Connect inside of Strubing Steel. Okay, this is the interface of Cype Connect. Okay, and here are the operations that were necessary to model this connection. Okay, actually, if I deactivate the connections here, you see the original situation that came from Cype 3D. Okay, so here actually this was the model that was imported, and then different operations, an adjustment, then a section cut. It's gonna be this one here, somewhere here, a lateral plate, then another section cut. All these operations were applied here, and the connection was modeled. And then with this model, we can analyze the connection itself, because now we have the loads that came from the Cype 3D model, for example, or we introduced it manually or from Excel, and then we'll have results related to the comparing these results with the code criteria, and then we'll know if it's safe or not. Okay. Of course, these elements can be then, we can have the sheets for these elements. For example, here, I'll just create a new, I'll just generate a new sheet with these elements. For example, insert some views here. For example, let me put it on hybrid. I can change here the sizes of the texts. I can change the scales of each one of the elements. Okay. Yeah, we use here the size of the paper is going to be A3 horizontal, for example, and the software will generate these connections for us, okay, or these drawings for us. Of course, here I can add a lot of details. I can change the sizes, I can change the styles, I can add this tags, texts, dimensions, tables. There is a lot of drawing elements that can be introduced here. Coming back a little bit, just to show one concept that I think it's very important for us in these last minutes of the presentation, it's the concept of assemblies, okay? When I decide how the elements will be welded or bolted, I can decide if they will be welded or bolted in the field or during the fabrication. And these parameters will set the assemblies for us. For example, here, I can use this little button to see which assemblies I have. The software can number these assemblies for us automatically, for example. And you see, let's just wait, the software finishes this part. Let me show to you one example of one assembly. For example, this truss here. Let me click here. You see, the elements there are welded. This part that is blue, they are welded in the manufacturing phase. They are welded to this plate, for example, you see that they are highlighted in this little blue line, but the bolt was introduced in the it will be introduced during the in the field, so the bolt is not highlighted. Actually, if I click here, I can open and create a drawing with just these elements, the assemblies that are available here. And you see that the plates are available in this assembly, the welds, but the bolts are not here because the bolts, they will be then introduced in the field. And here you can also create these drawings, or you can do some things like this, creating a table and inserting the parts that are available in this assembly. For example, here I have different plates with different sizes, different profiles with different quantities, lengths, and weights, and this information is introduced automatically here. Okay, and of course to the shop drawings, this is more precision. Here you have you don't have to introduce it manually, calculate it manually. It's generated automatically by the software. Okay, just finishing our presentation, remembering that you can export these files to the BIMserver.center platform again to integrate it in your federated model, or you can export it, as I said before, in the STV step or IEFC. Here you can also, for example, have your reports of the project and have the quantities as we have been talking before. So let me just see here, we can see the quantities for the assemblies, the sections, the plates, the bolts. Here you can also have the checks that we have for the connections that we analyze it. Okay, there are different types of reports available in the software. Okay, I think we can finish the presentation here. Actually, we are getting out of time. Just would like to thank you for your attention. Thank you if you have been here with me until the end. It was a pleasure, and I hope I can see you in a next opportunity. See you.